Okay, here we go. Today we're going to talk about hexadecimal, which is worth knowing once we get binary under our belt. So hexadecimal, otherwise known as base 16, hex, right? Hexadecimal. This DAC we talked about yesterday, this root word meaning 10. Hex means 6, so 6 plus 10, 16. Okay, the abbreviation, the subscript that you may see is hex as opposed to bin or dec. And you may be thinking, oh, well, isn't that base 6? Well, as you're going to see, like base 6 is just not really used. And base 16 is super useful, so we just use it here. Okay, so base 16 hexadecimal is a number system which uses 16 symbols to represent numbers, a positional number system, just like binary or decimal. The first 10 digits are self-explanatory. We're going to use 0 through 9. The problem is, this is what we're used to working with, and we're out of digits, right? In our decimal system, we only have 10. That's it. There's all 10. So after 10, right, these are the first 10, we're going to use letters, A, B, C, D, E, and F, to represent the numbers 10 through 15, respectively. Now, I know you're probably looking at 15. Isn't this hexadecimal? Yeah, keep in mind this 0, right? There are 16 different numbers. 0 through 15. So 0 is included, 15 is included. So those are our 16 digits, if you will, in hexadecimal. I know there's letters here, but those are the numbers that we're able to represent with just single symbols. Those 0 through 9 and the A through F. So recall that individual places in a number system, a positional number system, have a particular value. Right? When we're talking about decimal, to figure out the place value for this position, I'm going to do 10 to the 0. Why? Because I have 10 possible digits. If I move a position, I just change the exponent, right? If I'm doing, this position would be 10 to the 1 or simply 10, 10 squared or 100, so on and so forth. This is what we're used to working with, but this is how it works. When we were talking about binary yesterday, same concept. I have 2 possible digits in binary. I'm going to use a exponent to kind of track my position. And it also helps me figure out my positional number value. The exact same concept is going to work with any number system. You could just give me a number, and I would develop a positional number system from that. Here's how base 16 works. We have 16 possible digits. In order to track the place value or figure out what the value of the place is, I'm going to use an exponent. This first one is 16 to the 0. 16 to the 1, 16 squared, so on and so forth. And I don't go very deep because, as you might imagine, this increases quite quickly. So let's figure out these values. What is 16 to the 0? What is 16 to the 1? What is 16 squared? I'm not going to go too deep on these, and they are right here. So 16 to the 0 is 1. So this place has a value of 1. This place has a value of 16. This place, 256. And again, I'm not going to go much deeper because we don't really need to. So, with what you know, let's try to take 172 in decimal and convert it to hexadecimal. Just like with binary, what I'm going to do is look across here, find the value, find the largest value that I can put it to 172. In this case, it's 16. I don't know how many that is. We could pop up a calculator. Let's do that. I want to know how many times does 16 go into 172. That's going to be 10. So I'm going to put 10 here. Now, the thing is, we don't really have a digit, except we do. With hexadecimal, right, after we run out of those first 10 digits, right, 9 is the last out of those first 10, we then switch to letters. So the way that we represent 10 in hexadecimal is A. I'm going to put an A here. We subtract out the 160, right? 10 times 16. I subtract out 160. I am left with 12. Okay, I'm going to look across here and figure out what is the largest number that I can fit into 12. It's just 1, right? How many times does 1 go into 12? Well, it goes 12 times. Okay, recall we're going to be talking about letters here. So if this is 10, B is 11, 12 is going to be C. So I'm going to put a C in this box, which indicates 12. 12 times 1 is 12. I'm going to subtract that out. I'm left with nothing. So 172 in decimal is AC in hexadecimal. Okay, let's do another one. I have 1,337. and I want to convert it to hex. I want to look across here, find the largest number that will go into 1,337. It's 256. How many times? Let's ask the calculator. 5. Okay, so I'm going to put a 5 here in this spot. 5 times 256 is 1,280, so I'm going to subtract that out. I am left with 57. I'm going to look across, find the largest number that will go into 57. It is 16. How many times? Oh, come back to me. 57 divided by 16, we got 3 times. So I'm going to put a 3 here. And the question is going to be, what is 3 times 16? That's what we're going to ultimately subtract out. I'm left with 9. Largest number that will go into 9 is 1. It'll go in 9 times. I have no letters involved here in this particular conversion. Okay, so 1,337 in dec is going to be 539 in hex. So why don't we do one more conversion? I don't have one prepped in the slide, so I'll just do it on the fly. I'll go a little bit larger than 256. Well, let's go a little bit larger maybe than 4,096. Let's do something like, I don't know, 5,000, 5. Let's do like maybe 9,000. Let's go over 9,000. Okay. Random number, no idea. But I want to convert this. If I'm working with nothing, I need to basically create my tool, right? I need to figure out what these place values are. We're talking about hex. So my base is going to be 16. Ooh, here we go again. So we got 16 to the 0 is going to be this first position. 16 to the 1. 16 squared. 16 cubed, and I'll go ahead and do 16 to the 5th. Now to actually get these values, I just evaluate these things. All right, 16 to the 0 is just 1. Anything to the 0th power is 1. 16 to the 1 is just 16. 16 squared is 256. 16 cubed is 4,096. And this one I don't remember. What is the slides? Did I immediately go to 5 when I'm supposed to be at 4? That's part of the confusion. We're looking at 65536, which I don't even need this number. I'm not even going to ask you to know this number. But that's what it is. Okay, I want to convert this number. I'm going to look across, find the largest number that I can put into it. It's going to be 4,096. Let's see how many times that actually goes. I'm going to bring back up my calculator. Here it is. And so we'll take 9037 divided by 4096. It goes in 2 times. I'm going to put a 2 here. Right? And I need to subtract that out. So I'm going to take 2 times 4096. I want to subtract 9037 minus 8192. I'm left with 845. So we just did, we should probably write these down, 8037 minus 8192. And that leaves us with 845. I'm going to just pull this calculator over to the side here. There we go. Leaves us with 845. I'm going to look across, find the largest number that goes into 845. It's 256. I need to figure out how many times. So I will divide this by 256. I get 3 and some change. So I'm going to put a 3 here. We'll then multiply 3 times 256 to see how much to subtract. Leaves us with 768. So I'll subtract out that 768. Leaves us with 77. Okay. I'm going to look across, find the largest number that goes into that. It's going to be 16. We'll see how many times does 16 go in. 4 times. So I'm going to put a 4 here. And we'll subtract that out. So 4 times 16. I'm going to subtract out 64 from this. It's going to leave me with 13. I'm going to look across and find the largest number that goes into 13. That is 1. It goes in 13 times. Well, A is 10, B is 11, C is 12, D is 13. So this number represented in hex is 234D. Okay. Positional number system, it works the exact same thing, exact same way. The only quirk here with hexadecimal is that we run out of digits, right? And so we start using letters. So that's what makes it worthy of watching, of like teaching separate from binary. So I have a number file video here. This one is super interesting. It's going to talk about the letter F and how, basically hexadecimal starts using letters. I'll put a link in the description, and I will annotate or some things, add a suggestion so that you can find that one. There's also going to be this one. And I should say on this number file video, the best thing it shows, the whole reason why I want you to watch it, is it shows the relationship between 1 byte and 1 hexadecimal symbol character, right? I'm talking that 0 through F, right? 0 through F, let's take a look at this. Recall that our largest number that we could represent in binary was 255. With 1 byte. Okay, sorry. 1 byte, 8 bits. Why don't we back that up? Let's lay this out. I'm gonna copy this bad boy. All right. I'm using 8 here because typically in computer science, after a bit, we move up to a byte. And we're talking, this is going to be 2 to the 1, 2 to the 2. This is from yesterday's video, but it's worth kind of recapping because it explains everything. So I've laid out my 8 bits. That represents 1 byte. Here we're talking about binary, so I've got these things. We'll do the positional number of values. The maximum value I can represent, and we're talking binary, is if I had the maximum place value in every single position. Right? If all of these are 1s, this is the maximum value I can represent with 1 byte. And this works out to be 255, right? Because we just take 128 plus 64 plus 32 plus 16, blah, 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 blah. Okay, if I want to represent, let's look at what 255 in hexadecimal is. So I'm going to take this 255 and I'm going to go through a conversion where we convert it to hexadecimal using the exact same process that we've been doing. 255, I'm going to look across, find the largest number that goes into it. 256 is close, but 16 is actually the largest one that this will go into. So I'll take my 255, divide it by 16. We end up with 15.9, right? Again, it was close. 15, I actually have a symbol that represents that. It's the letter F, right? F, this is 15. So this is saying I have 15 16ths, or simply put, 15 times 16 gives me 240. So I'm going to take my 255, I'm going to subtract out 240. We are left with sorry. That's supposed to be like a really miraculous moment. We're left with 15. I'm going to look across here. The largest number that will go into 15, 16 is close, but it's 1. 1 will go in there 15 times. Okay, so 255 in decimal is FF in hex. So what that number file video shows, and I want you to watch it, but this is the largest takeaway, is that we can represent 1 byte exactly. We can represent 1 byte using only 2 hexadecimal symbols. And this is big, right? Because if you were to lay out this 1 byte as zeros and ones, right? Think about this could be any number in the range 0 to 255. This could also be any number in the range 0 to 255. But when you're looking at a lot of zeros and ones, that's so convoluted as a human. When we're talking about just looking at pairs of characters, it's so much easier to see what the number is. But this lines up directly. And that is ultimately the entire reason that hex is super important. Okay, so that's what this number file video talks about. Watch it; it's interesting. It features this dude that's like has the second highest score in Tetris. Honestly, he's a god. And then there's this code.org video that talks about pixels. And so I find this very interesting. I was looking at doing graphic design before pursuing computer science, and so I was kind of aware of this, and it's all very interesting. When we talk about pixels, we're talking about dots on the screen, right? The image that you're looking at right now is a whole bunch of dots, like thousands of dots, right? And they're all clumped together very close. Those are pixels. And pixels can have colors. Okay, so here is a color picker. You can just Google color picker as to find it. Obviously, the link is in the slides. But what I wanted to show you is the relationship, again, as expressed in that number file video, between essentially binary and hexadecimal. So I have colors that can jump around and click. That's pretty cool. But it shows you essentially what the color is here. So when we talk about colors, we use these things. They're called an Rgb triplet. This stands for red, green, and blue. And what I'd like you to notice is right away we see the number 255. Okay, and as you can imagine, 0 is a possibility. Let me do another color picker. One that's got like a slider. And I can, yeah. Yeah, if you just Google the color picker, there's actually one that's in the browser. I'm going to zoom in on it a little bit. But we have a slider here, and we can kind of play with this. I can also kind of, within that branch, play with this. And notice that these numbers they're changing. For one thing, it says very explicitly right here, hex. But it's directly related to these Rgb triplets. And notice that we can go all the way down to 0, right? So black is just 0, 0, 0. And if I slide it all the way up to the other end, white is all 255s. So this stands for red, green, blue, and this is basically just a range. You can think about it as a percentage, but that number is not 0 to 255. That number is not 0 to 100, it's 0 to 255. And so this number should jump out at you, right? We can represent the red portion, the red channel, with 1 byte, right? 0 to 255. The green, 1 byte. The blue, 1 byte. All right. So each pixel is actually going to add up to be 3 bytes. And then you have like an insane amount of pixels. That's not the important part. What I want you to recognize is that we're using 1 byte for red, 1 byte for green, 1 byte for blue. Now, based on what I just told you about that relationship between 1 byte and hexadecimal, you see that we have this. Well, as we just learned, we can use 2 hexadecimal symbols, characters, digits, whatever you want to call them, to represent 1 byte. And that's what this actually is. This is the red portion, this is the green portion, and this is the blue portion. And it directly corresponds with this, right? 81 and decimal is going to be 51 in hex. 145 in decimal is going to be 91 in hex. And so what you end up with is this thing we call the hexadecimal code for color. And you can just hand this code to whoever, and they're going to end up with the exact same color that you have. Okay, this is like super important when you're talking about designing websites. In fact, this W3 Schools site, that's what they specialize in, is talking about developing websites. Maybe you're designing a t-shirt, and you want to get the colors correct with your logo. And so you can just hand somebody the hexadecimal code, and they're going to have the exact color that you want. So we're going to wrap it up there. I'll see you in the next one.